Hello and welcome to today's presentation on understanding industrial and operational technology cybersecurity risk. My name is Megan and I will be your moderator for today's webinar. Today's presentation will be presented by Nigel Stanley. Nigel is the Chief Technology Officer for the Global Operational Technology Cybersecurity Center of Excellence at TÜV Rheinland. A specialist in cybersecurity and business risk with nearly 30 years experience in the industry, he is a well-recognized thought leader and subject matter expert capable of delivering complex cybersecurity projects across small, medium, and large-scale enterprises. Nigel has written 3 books and is a regular speaker at international events and conferences. He is also a chartered engineer and member of the Institution of Engineering and Technology, Institute of Electrical and Electronic Engineers, and the British Computer Society. He has an MSc in Information Security from Royal Holloway, University of London. For today's presentation, each of you is in listen-only mode. We encourage you all to submit questions via the chat box function. Questions will be answered during a question and answer session at the end of the presentation if time permits. Also, please note the presentation is available for download in the handout section. At this time, I'd like to turn things over to Nigel. Nigel, please go ahead.
Thank you, Megan, and thank you all for joining us for this webinar. So for the next 30 or 40 minutes, I'm just going to run through a presentation that should hopefully start to position some of the issues that I'm starting to see around operational technology and industrial cybersecurity risk. So as Megan says, I've been in the industry for many years, and I have to say this is a very exciting time to be involved in industrial cybersecurity. It's very vibrant, we're facing many challenges and many threats, and it's an exciting time for us to get a grip on some of those risks and put in place the appropriate controls and measures to ensure that businesses can succeed in manufacturing, in transportation, and so on. So as I mentioned, the webinar presentation will last about 30 or 40 minutes. I intend to talk about modern industrial cybersecurity risk, and just to put some context around the problem as we see it within TÜV Rheinland. I'll then be talking about functional safety and cybersecurity, and the importance of safety and cybersecurity now being addressed as one. And then finally, be finishing up with a discussion around how you can assess your cybersecurity risk in your business or your organization. So let's start off with painting the picture around what I consider to be modern industrial cybersecurity risk. Everyone would agree that society today is hyper-connected. We're on 24/7, we're always available to work colleagues and to our social colleagues and friends as well. So therefore, cyber risk is now permeating all aspects of modern life. And the world of industry, the world of operational technology is absolutely subject to a whole raft of cybersecurity risks. To me and to TÜV Rheinland, what we mean by operational technology and industrial cybersecurity very much relates to many different sectors. Those sectors can be manufacturing, it could be transportation, such as railroad systems. They could be utilities. They could be energy generation, so wind turbines or solar panels. Autonomous vehicles, industrial refineries and processing plants, telecoms, and even the humble elevator. So building management systems are now part of the domain and are increasingly at risk from cybersecurity threats, as are all the other areas. No doubt everyone on the call has heard about the Internet of Things, and I like to consider the IoT to be the small things, the small gadgets, whereas the industrial Internet of Things is the big things in life, the big machinery, the big equipment that if it goes wrong can cause some significant problems. So this is the domain that we're talking about when we talk about operational technology. Of course, anyone that's worked within information security or cybersecurity for any length of time would be very familiar with the notion of confidentiality, integrity, and availability. So these 3 aspects really sum up the world of information security nice and neatly. So confidentiality is ensuring that the data is kept confidential or secret when it needs to be, and that's often using technologies such as encryption to encrypt data. We have the integrity of data, the importance of making sure that as data goes from point A to point B, that it isn't altered or changed. So very simply thinking about a banking transaction, if you wish to transfer money, you wish to make sure that the correct amount of money goes from one account to the other. And then finally we have the availability of systems. So by availability, this is ensuring that systems are available to the right people at the right time in the right place. So CIA very much sums up the world of information security. The world of OT cybersecurity is somewhat different. Absolutely, we are concerned about confidentiality, integrity, and availability of data, but we're also concerned about safety of systems, safety of processing plants, and so on. But also privacy. People think, well, why should we be concerned about privacy within the world of OT? We'll be coming on to that a bit later. But if you just think privacy, safety, and security form the basis of what we consider the key basis of operational technology within TÜV Rheinland. One thing I have seen is a huge increase, a dramatic increase in publicly announced industrial control system vulnerabilities over the past few years. I like to think that hacking is very much like the fashion industry, and it comes and goes in waves. So maybe 10 years ago, the humble smartphone gained the attention of hackers, and hackers were intent on breaking into those devices. Now, we very much see that industrial control systems are the target of hackers and activists alike. And absolutely, nearly every vendor of ICS products is affected by vulnerabilities. And a real tough challenge is how on earth you can patch these systems if these systems are operating 24/7 on a processing plant. You can't possibly take the systems down to patch them. It's really difficult. And we start to see common vulnerabilities right across industrial control systems. All of the things that we've seen before within normal IT systems being replicated within ICS. So these include your memory buffer overflows, the unauthentic protocols, the use of passwords embedded into the code on the devices, and so on. So very much it's a big attention from the various hackers and activists that are taking advantage of these common vulnerabilities to hack into systems and to subvert systems. The impacts of industrial cybersecurity incidents can be quite dramatic. In contrast to IT systems, where generally failure of an IT system wouldn't necessarily result in a particular fatal accident or injury, it could be said that an industrial cybersecurity incident could potentially lead to injury or fatal accident in extremis. Of course, we have financial loss. So as you would expect, if you're operating a 24/7 processing plant, the processing plant should cease to work, you're not producing the product, therefore you're going to incur financial loss. That will then impact shareholder confidence. So shareholders will start to question the viability of the organization, the business, and indeed whether future investment should be placed. And I've spent a lot of time in my career talking to shareholders about cybersecurity risk and explaining to them the difficulties of ensuring that the organizations that they invest in are as secure as they can possibly be. We can have destruction of property, and certainly in some jurisdictions in the Far East, many countries are now putting in place some significant new regulation to deal with the possible destruction of property following a cybersecurity incident. So now if you operate a major hazardous industry in, say, Singapore, as part of your safety case, you'd be expected to address cybersecurity risk on the basis that you can no longer be safe if you're not secure. Of course, we have public image, and we'll be talking about that in a minute or so, but the public image of the organization or the business can be severely damaged or tarnished by a cybersecurity incident. And then we have my favorite, which is intellectual property. So your designs, your machinery settings, your secret sauce recipe are all at risk of theft by people that are interested in your intellectual property. And this is being done on a wholesale basis internationally right as we speak. So very much industrial cybersecurity incidents can have significant impacts on any business that should have the misfortune of tripping across them. Here are some examples of the impact in terms of the reputation and the public awareness and how your organization could be on the front page, but for the wrong reasons. So we've had issues where major steel mills in Germany have been hacked, causing significant damage. We've had ransomware, which hit towards the end of last year, impacting production lines. And in this case, we have motor vehicle manufacturers that have been prevented from running their plants due to ransomware attacks. And then we even have food manufacturers who have to shut down their factories due to a cyber attack in the form of ransomware. The railway and railroad industry is at risk as well, and this is an area where TÜV Rheinland spend a lot of time and effort and work a lot within the safety of railway systems as well. Here you see an example of ransomware impacting the station screens, the timetable screens within a station in Germany. If you were a passenger about to board a train and you saw a ransomware message appear on the screen, maybe you'd start to question whether it's safe to go on that train or not, if the systems could be subject to these types of attacks. And as we move into digital railways, with the likes of positive train control in the United States, or the European rail traffic management systems in Europe, those systems can absolutely have the potential of being subverted through a cyber attack. So the entire domain of railways is a very interesting one, and is a great example of the manifestation of these types of issues and these types of problems. And the barriers of entry for someone interested in undertaking some form of a cyber attack against these systems is actually quite low. So there are publicly accessible websites that are designed to provide information about industrial control systems. And these websites will actually highlight industrial control systems that have got weaknesses within their security posture. There are discussion groups, there are books, there's all sorts of resources available for people interested in attacking these systems, be they industrial control systems or SCADA systems and whatnot. So the barriers of entry are quite low, which is again why it's starting to attract the attention of hacktivists, script kiddies, as well as some more sophisticated attackers. If we look at the example of a manufacturing plant, these are the attack vectors and some of the issues that we see when we talk to our manufacturing customers. So the first problem is something that I've seen for many years, which is the issue around mobile working and smartphones. So users using smartphones inside the plant. And of course, every smartphone now has a camera. They use the smartphones outside of the plant. Maybe they gossip on social media. Maybe they discuss a new contract, or they discuss a new control measure you have in place, again, leaking information about the factory and what you're up to within the production line. The move to cloud systems is now essentially doing away with the physical perimeter for security that many organizations will be comfortable with. So now the cloud systems can result in your data, your intellectual property, your customer data residing on the other side of the world, which again actually presents some issues in terms of cybersecurity. Manufacturers of new capital equipment would now, I would contend, expect to have access to that equipment for maintenance purposes. Maybe it's preventative maintenance, maybe it's reactive maintenance. But the equipment needs to connect to the internet either through wireless or a hardwired connection, so the manufacturer can connect to that piece of equipment and then undertake the appropriate maintenance or technical support. So what does that mean? Well, your data could end up being accessed again from the other side of the planet as someone remotely connects to your production line to determine what the problems are or to put in place appropriate fixes. So again, your data could reside anywhere in the world. And also you have the challenge of how do you provide such access in a way that is safe and secure. And then of course legacy systems, so older equipment that is maybe in the transition process to a new way of working or is in the process of being updated, may inevitably have cybersecurity related risks and challenges with that as well. So all of this together presents quite a challenge for manufacturers that are maybe adopting Industry 4.0 or are moving to a new manufacturing set of hardware. You now have to think about the cybersecurity risk. But key to this is a supply chain. Modern just-in-time production plants have a very lean supply chain. The supply chain will often span the world, and it will use components and parts from many, many different vendors, supplied just in time to make sure that the production line can keep on working. So any large manufacturing plant could have hundreds of these third-party vendors and suppliers and contractors. How on earth can you secure the supply chain? How on earth could you manage the fact that people involved in delivering your products and your services could come from very diverse backgrounds right across the world? And in some cases, these people may not have your best interest at heart. The supply chain is often the weakest link. Many organizations that we work with may have a very good security posture inside the organization. You then start to ask questions about the supply chain, and then it starts to raise some problems because they haven't enforced decent cybersecurity measures across the supply chain. So I would urge you, if you do have a simple or complex supply chain of any sort, have a look at that and decide what the cybersecurity risks might be in some of your contractors or suppliers. Of course, some people will say to me, well, we don't need to worry about cybersecurity risks because we have an air gap. Now, an air gap is a way of a control measure that basically says that your production plant, your production facility is not connected to the internet. There is no wireless and no hardwired connection between that system and the internet. Therefore, you have this air gap and you are secure. I would say, in fact, that the air gap is now a myth. With the prevalence of smartphones, with USB sticks, with Wi-Fi's, with cell phone access, your network is now really never going to be air gapped. You now need to consider that any industrial network that you're running is actually somehow in some way going to be subject to either these USB sticks or connections to the internet. Therefore, just assuming that the air gap will be the best control measure is simply not the case anymore. So even if you have that thought, maybe put that to one side and consider other ways in which your network is actually connected somehow to the internet or the outside world. I mentioned privacy a bit earlier on, and anyone that follows privacy issues will be very familiar with what's happening with various providers on social media. Certainly one very big challenge we have within the EU is the General Data Protection Regulation, or GDPR. This was actually enacted a couple of years ago, but will be enforced from May of this year. And GDPR is a huge change to the way that personal data that originates from Europe is actually managed and processed. And you think, well, why should this impact me in my OT network? Well, the reason is that a manufacturing plant we recently did some work with, they use some equipment that does some ultrasonic welding. And the welding equipment actually captures the name and the email address of the operator. And it captures this for quality assurance purposes. So the manufacturer of the equipment who is based outside of the EU, is actually taking this data outside of the EU and then aggregating it within their systems, in this case in the US. Under GDPR, that is actually an export of personal data. So when I spotted this, we were able to have a conversation with the manufacturer and with the manufacturing plant to say, look, this is going to be a problem for you unless you have the appropriate measures in place. So don't think GDPR is just an IT issue. It's not. It's an issue for your entire organization. And if you have responsibility for OT networks, just give this some thought to make sure that you've addressed any of the issues behind this. So what about functional safety and cybersecurity? Well, we now know what cybersecurity is, and we understand the fact that it's defending against these negligent and willful actions. And to this point, I would say that the vast majority of cybersecurity incidents that we deal with are due to someone being incompetent and non-malicious. This is an individual who makes a mistake. They send an email to the wrong person, they don't configure a firewall appropriately, and so on. On the other hand, a competent and malicious hacker is actually quite rare in the great scheme of things. So do think about people making mistakes with your equipment, making mistakes with your systems, as well as some of the more nefarious hacking attacks. So by functional safety, what we're talking about here is very much defending systems and making sure that any system will fail in a safe way, and it will actually protect life and environment as part of that. And cybersecurity and functional safety are now absolutely coming together. This is reflected within IEC 61508, which is a very good generic standard for functional safety. And within that, it's now codifying the fact that if you're looking at the safety aspects of a process, of a thing, of a device, you need to understand what the security threats are with that device or process. It refers you to IEC 62443, which is an excellent system, which we'll be discussing in a second. And this enables you to understand a bit more about your cybersecurity risk. But now we have acknowledgement within one of the key standards that safety and cybersecurity are coming together, and you need to consider that within any of the safety case related work that you're doing. 62443 has got 7 foundational requirements, and these wouldn't be really too strange to an IT security person, but from an OT point of view, they really are tailored to thinking about operational technology. So for example, making sure that you're managing the way that multiple operators would access equipment on the factory floor, in terms of the right person being able to access the right equipment at the right time. We're talking about data confidentiality. We're talking about system availability. Foundational requirement 5 talks about restricted data flow. And this is a big issue within operational technology networks, when at the very top of the tree you have your enterprise resource planning, your ERP systems that may need to communicate to factory floor systems. How do you manage that data flow in a way that key data doesn't go back into the ERP system when it shouldn't, but more importantly, the link to the ERP system doesn't open up a channel for hackers to come in through the IT network? We also need to consider patching, how these systems can be patched, how they can be updated when you need to maintain, under resource availability, a 24/7 processing plant. But the good news is that IEC 62443 does pull these together in a very nice, usable way, and this is certainly one of the standards that we use when we undertake cybersecurity risk assessments. Formally, we're now mapping together functional safety and cybersecurity in a typical work life cycle. So now when you are designing in the R&D phase a product or a service, absolutely a hazard and risk analysis needs to be conducted to determine the safety issues associated with that thing that you're working on. Now, functional safety is very deterministic. That means that my colleagues who work in functional safety can mathematically prove that a system is going to be safe from their viewpoint, and they can actually apply a SIL factor, an SIL factor, which can determine the probability of a dangerous failure. So this is nice and neat and nicely wrapped up. Cybersecurity, on the other hand, is non-deterministic. And it's a real challenge when people say to me, well, can you prove that the system is secure? Because you can't ever be completely and utterly secure. But what we can do is undertake a risk and threat analysis. And the recommendation is that this is done very early on within the product, the system, the process development, so that we are addressing those risks and threats very early on, right at the start. Then using the IEC 62443 standard, we can then start to determine the best way of protecting that system and the appropriate security level. So 62443 has got 4 levels of security levels, starting off at the very basic level, saying protecting against coincidental violations, so very low level kind of accidental security breaches, if you like, moving all the way through to SL4, which is ensuring that the system is protected against a sophisticated attacker with extended means and capability. Now, in reality, the vast majority of organizations that we work with really only want to certify to SL1 or SL2. Very few organizations would have the time, the budget, or the ability to actually implement SL4 simply because the requirements are quite significant. But now within many organizations that we work with that maybe produce a programmable logic controller, a device, then they're looking to have that certified to SL1 or SL2, as well as having a SIL rating against that device as well, really bringing together both functional safety and cybersecurity. What really highlights this issue was a seminal moment in December last year, when it was announced that there was the first publicly announced, certainly, attack against a safety instrumented system. So this system was using a Triconix PLC, a Triconix SIS controller, and the attackers had managed to compromise this controller to subvert it. So it was what appears to be a deliberate targeted attack against a safety system. And that's the first time that we've seen that announced publicly. Now, the details behind this are very sketchy. It's believed that the SIS controller was actually in an organization likely to be in the Middle East. And the attribution, which is a real problem when it comes to cybersecurity attacks, was likely to be a nation state simply because of the sophisticated nature of the attack on the systems. But what is interesting is that the SIS controller has got a key setting on it that can determine the mode that it's operating in. And the SIS controller had actually been left into program mode. That enabled the attacker to compromise the controller. If the key setting had been moved back to run or remote, then that programming malware, the malware, would not have been able to be loaded onto the SIS controller. So a very simple physical security measure, i.e. the turning of the key lock, could have prevented a very sophisticated nation state alleged attack. So when you think about cybersecurity, yes, you think about safety, yes, you think about sophisticated attacks, but often the basics will win. So basic cybersecurity hygiene is very important. So what about assessing cybersecurity risk? So we work with manufacturers, systems integrators, and systems operators. So a manufacturer would typically be building a component such as a programmable logic controller, a PLC, or a system. A systems integrator will be then taking those components and systems and then building a larger solution to meet an operator's specifications, and then systems operators are the folks that are running the plant, running the manufacturing plant, and what have you. Every one of these types of players has to actually implement some form of a risk assessment. So manufacturers need to be focused on risk assessing their components. The integrators need to think about the solution, and absolutely the operators need to think about the cybersecurity of their factory or their operation or production facility. The risk assessment approaches that we would generally recommend fall into these two categories. The first one is using the NIST cybersecurity framework. And this is a very good framework to identify how some of your key risks are going to be managed within your OT network. It enables you to take advantage of some of the NIST publications and best practices and guidelines, but also compare how your organization will stack up against maybe other organizations within the same sector. Very importantly, it helps to address the question of the CEO or the C-level executives who says, how are we doing? How are we addressing our cybersecurity risk? And this framework enables you to provide a maturity assessment, a maturity model in support of that, and then put in place, using this more informed way, various controls to strengthen your OT cybersecurity practices. On the other hand, IEC 62443, which we discussed earlier, is a very good mechanism for providing the security levels and an assessment against systems. Based on the 7 foundational requirements, you can provide a security level, and this is good to be used by anyone through manufacturers or systems operators or integrators. Certainly in our experience at TÜV Rheinland, the NIST cybersecurity framework as a maturity model is often a lighter touch for this type of work. It enables organizations to do an initial assessment that is maybe rigorous, but not as aggressive as 62443. So certainly my recommendation, if you are new to this type of risk assessment, is maybe to have a look at the NIST cybersecurity framework. If on the other hand, you are a manufacturer, or you have a need for a particular security level rating, then absolutely 62443 is the way to go. But we can advise you on that if you wish to have a chat with us. Of course, the recommendations that we produce when we undertake risk assessments are produced in a way that most people can understand. And quite frankly, we make best use of a RAG, the red, amber, green status. We have the maturity ratings, the risk ratings, and what have you. And the beauty of the approach that we take is that we can fine-tune the risk ratings based on your business. Likewise, any of the findings and any of the effort required to address any of the findings, that can be tailored according to your business as well. So you have the ability to change some dials to really customize this to your organization to provide you with a very good concrete set of risk assessments, but also a path forward to address any of the issues that have been found. So what are the next steps? And hopefully you've enjoyed listening to some of the issues I've been talking about. I would say that absolutely number one is that you need to understand your risk. I don't think you can now operate any sort of operational technology plant with unbounded cybersecurity risk. You need to somehow get your head around where are you in that threat continuum with regards to cybersecurity. You absolutely need to regularly monitor new and emerging cybersecurity risks on your network. So we're starting to see regulations and standards that are saying you have to have some form of OT network security monitoring in place to detect any threats that might emerge, because this is such a volatile, dynamic field. So this is something that the world of IT has been doing for quite a long time. OT network monitoring is a bit more complicated due to the varying protocols and whatnot that often are found. but we need to address this, and we need to have in place some form of monitoring. You need to understand how this new capital equipment, how other manufacturing suppliers are providing you with products. Great, these new connected systems can enhance productivity, but what about ensuring that they're implemented in a way that address cybersecurity risks? And finally, watch out for this new and emerging legislation and regulations. There will be, I guarantee, more regulations expecting you to address cybersecurity within your industry. These aren't only going to be cybersecurity, they include privacy issues as well. So have a long, hard look at some of this as it applies to you, and maybe take advice in what's happening in terms of legislation and regulations coming down the line that can impact your business. So that's it from me in terms of the formal presentation. I hope you enjoyed that. I'll now hand back to Megan.
Thank you, Nigel. We received a number of questions from the attendees during your presentation. The first question is, how can I convince my boss to free up funds for an OT risk assessment?
I guess it depends on your relationship with your boss. If your boss is an executive level, then all they're going to want to hear about is business risk. So don't talk about the weeds and the detail of operational technology and cybersecurity. Talk about business risk. Talk about the slide I mentioned earlier. We'll talk about reputational risk and shareholder value. Hit some of the key buttons that you know will motivate your boss to invest some time and effort on this. I'm very cautious about scaring them by saying you're going to be subject to loads and loads of cyber attacks. I would suggest you take a more proportionate, more mature view to this, but absolutely talk about it in the context of business risk.
Okay. Second question, should management of the OT network sit with the IT department?
So we see different versions of how the OT network is managed from a cybersecurity point of view. Many organizations will say the IT department is not to touch or get anywhere near the OT network. And that's because a traditional IT person does not understand operational technology, and the controls and the measures they have in place for IT aren't always necessarily applicable to the OT network. So I've seen situations where the IT department is responsible for managing the IT network, and the OT network and OT cybersecurity is responsibility of the plant maintenance team. And these are the folks with the screwdrivers who are there to fix equipment when it goes wrong. Again, that isn't necessarily the right way of doing it. The answer is who understands cybersecurity risk and who understands OT. Fine if it's the plant maintenance team, fine if it's the IT department. But as long as they understand that the world of OT is different to IT, then that's the way forward. But yeah, it's a difficult question to answer, and there's no right or wrong. It depends on the organization.
Okay. Third question, is there a way to manage OT, IT, and physical security in one go?
I guess this is a magic wand, the ability to get all of this done under one hat, maybe one person. Certainly the past few years, we've seen a desire by some organizations to move to converged security. And this is where physical security is now coming under the domain of IT security. And certainly if you look at a building management system that manages the security systems, CCTV and what have you, are inevitably going to be IP enabled. Then inevitably it's going to be an IT solution. Likewise, we've talked about OT versus IT. So again, I think more informed organizations will say, let's bring this together under one head, and that will be in charge of converged security. And I think there's an enormous amount of value in taking that approach if you can make that work for your organization, and find someone that is competent on physical security and competent on IT and OT. And those skill sets are actually quite rare to find in one person.
All right, next question. How quickly can you undertake a risk review? Does it go on forever?
I hope it doesn't go on forever. It's surprisingly quick, and certainly my experience is that we can undertake a risk review in a matter of days or a couple of weeks quite quickly rather than months. Again, there are lots of caveats. It depends on the size of the organization, the number of sites, but with a well-informed practitioner, someone that really understands the issues behind OT cybersecurity, we can crack on through a risk assessment quite quickly. Obviously, it'd be a mix of on-site and off-site work and what have you. So very much I would say it doesn't go on forever, and it's a matter of days and a very few weeks at most rather than months.
Okay, and the final question that I see here, there is a lot of talk of nation states hacking industrial systems. Is this for real or is it made up by the media?
Well, I don't really want to discuss the rights and wrongs of the media and whatnot. I think, as we saw with the Triton attack, and the attribution for that is absolutely being pointed at a nation-state actor. If we look at the Stuxnet attack a few years ago, that impacted some of the facilities within Iran that are responsible for enriching uranium, then absolutely the level of sophistication of those attacks could really only have been conducted by a nation state. In other words, an organization with significant resources and horsepower behind them to actually undertake the attack. Recently, there was a publicly announced report that was jointly created by the US and UK government security bodies that actually talked about nation-state hacking of critical national infrastructure and industrial systems, and they actually did name a nation-state actor in that report. So I think we can absolutely say, even if we're not 100% given all of the evidence, because the evidence is often tied up in secrecy quite rightly, I think we can be assured that certainly nation states are undertaking these sorts of attacks. And very importantly, it's up to us to put in place the decent cybersecurity controls to make sure that it doesn't impact our own organizations.
Okay, thank you, Nigel. If we did not get to your questions today, we will make every effort to get an answer to you soon. As a quick reminder, if you did not download the presentation and would like a copy, please do so now in the handout section. We hope you found this webinar informative and that you will join us for future webinars. Thank you and enjoy the rest of your day.